Hi everyone, my name is Yingruo Fan. I'm going to talk about our paper, FaceFormer Speech-Driven 3D Visual Animation with Transformers. This is a joint work with Zhao Jianlin, Jun Saido, Professor Wenping Wang, and Professor Taku Komura. A short introduction of FaceFormer. Given the raw audio, FaceFormer autoregressively predicts a sequence of 3 face motions. It achieves realistic animation of the whole face, including the upper face motions and the mouth movements. Let's look at a video produced by our method first.
Sad white boy, perturbed woman, angry blue man and a green guy.
얼굴 애니메이션은 가상현실과 같은 많은 응용 프로그램에서 개발되었습니다. L'animazione facciale è stata sviluppata in molte applicazioni come la realtà virtuale.
There are 2 types of works for speech-driven visual animation. For the 2D-based methods, they aim to generate the 2D video frames for the target person. But for the 3D mesh-based methods, the output is the mesh animation. And our goal is to produce realistic 3D visual expressions as well as accurate lip motions from the speech. So in this work, we focus on animating the 3D mesh. For the 3D-based methods, some papers use the procedural approach for speech animation or predict the rigging parameters from the speech. Some obtain the visual expression parameters as the ground truth. And another line of works use the 3D vertex offsets as the output. Similarly, in our method, we use the mocap data for training, and the output is the 3D vertex offsets. So in this paper, our motivation is that visual expression is more correlated with the speech emotion, which can be inferred from the long-term audio context. So in this paper, we formulate the problem into a sequence-to-sequence learning framework based on Transformer. Compared to RNN, Transformer can better capture the long-term context dependencies based on attentions. We propose FaceFormer. Basically, it's an encoder-decoder architecture. Let's look at the encoder first. Since Transformer is a data-hungry model, it requires lots of training data. However, there are a few public datasets that include both speech and the 3D face scans. To handle the data limitation problem, we explore the self-supervised pre-trained speech model with WebTVec2. The overall design of FaceFormer encoder follows WebTVec2. So given the raw audio, first, several temporal convolutions are used to generate the feature vectors. Then we add the linear interpolation layer to resample the features. And finally, a stack of multi-head self-attentions are used to encode the long-term audio context. For the decoder part, we introduce the periodic prediction encoding to make FaceFormer more generalized. PPE recurrently injects the prediction information to each period, and all the prediction embeddings have been seen during the training. In theory, this can improve the generalization to the longer sequences. In addition, we also introduce the temporal bells. Here, the temporal bells has 2 effects. First, it brings relative prediction information to PPE. Second, it assigns higher attention weights to the closer period. Since our problem is a cross-model problem, so we also add an alignment bias to align the audio and motion modalities. In our experiments, we use 2 public datasets, BOE dataset and the VOCA set for training and testing. Both datasets provide the speech and the 3D face scans, and we compare our method with 2 related works, VOCA and Mesh Talk. Let's look at the results on the BOE dataset first.
I specifically reminded her, bedside table on the kangaroo.
And I look forward to sharing that great life with you. Thank you for marrying me.
And the results on VOCA set.
The diagnosis was discouraging. However, he was not overly worried.
Small farms west of Fairbanks cater to whom?
And more results produced by our method.
Fly me to the moon and let me play among the stars.
Today, like millions of other families across America, Michelle, Malia, Sasha, and I will sit down to share a Thanksgiving filled with family and friends.
For more video results, please check out the project page. The code is also available. Thank you for your attention.